When the first shots are molded, cheers for successfully creating the tool and a molded part can be short-lived when it's noticed to have warped to a shape deemed unsuitable. With Autodesk Moldflow software, you can not only understand why your parts morph, but you can also experiment with the different tooling design, part design, and process scenarios to help get the high-quality part you expect before creating the mold. When you perform a flow and warp analysis inside Moldflow, the expected deflection based on part, feed, and cool design is simulated, so you can see how much it meets with fit and function requirements per the specifications. Whether your part has an assembly or sealing surface that must be flat, features that enable you to snap or screw it into other parts, or general dimensions and geometric tolerances that must be met, understanding these constraints while reviewing Moldflow's results is critical. This is because of the options Moldflow has available to customize how warpage and shrinkage are displayed for better interpretation and comparison. When initially reviewing the deflection plots, a best fit is applied to reference the measured values. This can be adjusted to user-specified planes or nodes to reference more closely to fit or tolerance requirements. For example, if the window of this GPS fascia must fit perfectly around the screen for the GPS, changing the reference plane or anchor plane to a few nodes surrounding the opening helps understand directional warp and shrink that must be planned for. When working with small values, increasing the scale option for the deflection plot in Moldflow enables you to review the directional trends. Notice when changing the value in the visualization tools, the value remains the same. They are just magnified visually. Thus, the shape does appear much more warped. If troubleshooting the deflection of your part, enable the option for running the warp analysis with the Isolate Cause of Warpage option, enabled within the process settings. This creates additional result plots that help paint a clearer picture to identify if warpage is due to one or all of the three major causes: differential cooling, differential shrinkage, and orientation effects. Back to the GPS plate, the main cause for deflection is differential shrinkage. Understanding this, considerations such as inserting additional cooling to aid in uniform shrinkage, increasing injection time to reduce excess material shearing, or changing the gating location may help to reduce the overall deflection. Understanding the cause helps to work backward and identify ways to reduce either overall or warp in specific locations. With any iterative process, changing one thing can result in other changes. So continuing the process of reviewing results and making small changes until an acceptable deflection is achieved is crucial. Moldflow's injection molding simulation tool aids in reducing risk for costly tool or part design changes due to unexpected behavior of the polymer during manufacturing. The warpage visualization tools in Autodesk Moldflow help you to identify, troubleshoot, and ultimately allow you to mitigate the risk of getting that surprise when molding the first shots.